Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. The operating system acts as the central control point for all applications, tasks, devices, and user access on a computer system. Its responsibilities extend from the moment the system powers on until shutdown, coordinating resources and ensuring stability. By managing processes, hardware interactions, and user permissions, it helps maintain security, performance, and reliability. The Tech Plus certification includes coverage of these core responsibilities to prepare candidates for practical IT roles. One of the primary duties of the operating system is launching, monitoring, and terminating software applications as needed. It manages how the central processing unit and system memory are allocated among programs, making sure no single application monopolizes resources. The operating system resolves conflicts between applications and background services, preventing crashes or instability. It also uses file associations to determine which installed program will open a given file type when selected. The operating system manages all running processes by assigning priorities and distributing processor time among them. This scheduling enables multitasking, allowing the system to rapidly switch between programs so users can run several applications at once. Many background services continue running unseen, supporting network access, updates, or hardware monitoring. Tools such as Task Manager or Activity Monitor provide visibility into these processes and allow users or administrators to adjust them. Processes in an operating system can run in the foreground or the background. Foreground processes directly interact with the user, while background processes carry out maintenance or synchronization tasks without interrupting workflow. The operating system balances these process types so that important work remains responsive and background activity does not consume excessive resources. While some background processes can be stopped without harm, others are critical to system operation and stability. The operating system uses process priority to determine how much processor time each program receives. High-priority tasks are given more immediate access to resources, while lower-priority tasks wait for availability. This system helps maintain performance under heavy workloads. Advanced users or administrators can manually adjust process priorities through system tools, but improper changes can slow performance or cause instability. Understanding how to use this feature effectively is important for system optimization. The operating system is responsible for detecting, configuring, and monitoring hardware devices connected to the system. Each hardware component communicates through a driver that acts as a translator between the device and the operating system. Plug-and-play support allows many peripherals to be automatically recognized and configured. Device Manager in Windows and similar tools in other systems allow users to check status, update drivers, and troubleshoot hardware issues when they occur. Input and output coordination is another key role of the operating system. Input devices such as keyboards, mice, microphones, and touchscreens send data to applications through the operating system. Output devices such as monitors, printers, and speakers receive processed data from the operating system for display, printing, or playback. Proper configuration ensures that user commands are recognized and that output is delivered to the intended device. Malfunctions in this area can cause delays, errors, or loss of functionality. The operating system also manages storage devices and the file systems they contain. This includes formatting drives, partitioning them for different uses, and mounting them for access. It keeps track of available space and allocates it to applications and users as needed. Built-in tools allow the system to check disk integrity, optimize performance, and repair errors. File system health is vital for both speed and security, as corruption can lead to data loss or operational issues. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. The operating system also controls and configures a wide range of peripheral devices such as printers, webcams, speakers, and scanners. Built-in configuration tools allow users and administrators to set default devices, adjust preferences, and address errors. In many cases, network-connected devices are detected and added automatically, but the operating system still manages driver installation and compatibility. Features like printer queue management and driver configuration ensure that devices operate efficiently and reliably. Another important function of the operating system is managing power consumption through settings for system sleep, hibernation, and shutdown. Power profiles can be tailored for maximum performance, balanced operation, or energy savings depending on user needs or battery status. Hardware components such as the central processing unit and display can be throttled or powered down automatically to save energy. In some cases, systems may wake from sleep to install updates or perform maintenance tasks scheduled by the operating system. The operating system handles the installation and removal of software applications, whether through built-in installers, app stores, or package managers. This process includes adding registry entries in Windows, managing permissions, and checking for software dependencies. Uninstallers remove associated files and settings to maintain system cleanliness. Incomplete or poorly executed uninstalls can leave residual files that consume space or cause configuration conflicts, so proper removal is important for stability. Access control is enforced by the operating system through user roles and permissions. Accounts may be designated as administrators, standard users, or guests, each with specific rights and restrictions. Administrators have full control, while standard accounts have limited capabilities to prevent accidental or unauthorized changes. Access rights determine who can install applications, modify system settings, or view sensitive data. Role-based access not only improves security, but also simplifies troubleshooting and support. System resource monitoring is an essential role of the operating system. Tools such as Task Manager in Windows or Activity Monitor in macOS track the usage of processor power, memory, disk activity, and network bandwidth. This monitoring helps identify performance bottlenecks or malfunctioning applications. Logs generated by the operating system can reveal patterns such as repeated crashes or failed hardware initialization. Alerts and thresholds can also be configured to warn users or administrators of abnormal activity. Logging and event monitoring provide a historical record of operating system activity, application errors, and security events. These logs are essential for auditing, troubleshooting, and meeting compliance requirements. Windows offers Event Viewer, while macOS provides the console application for reviewing events. By regularly examining logs, IT staff can detect underlying problems, verify system changes, and plan preventative measures to avoid recurring issues. Operating systems also manage system services and automated tasks. Services include processes for syncing files, applying updates, or monitoring network security. Administrators can adjust startup settings to enable or disable specific services, influencing performance and boot times. Automation tools such as Task Scheduler in Windows or cron jobs in Linux can run tasks at set times or under certain conditions. Misconfiguring services or automated tasks can delay startup or cause unnecessary resource usage. Troubleshooting at the operating system level often involves isolating issues based on which component is affected. For example, a misbehaving application that uses excessive memory, a printer that fails to respond, or a user who cannot access a file each require different oxygen monosulfide level tools. Knowing how to select and apply these tools effectively helps reduce downtime and improve user satisfaction. Mastery of this process is an important skill for IT support professionals. The Tech Plus certification may present scenarios requiring identification of which part of the operating system handles a given task. Questions may involve assigning priorities, diagnosing performance problems, or determining correct tools for managing files, devices, and permissions. Understanding which operating system feature applies to a specific problem ensures accurate and efficient troubleshooting. Matching tools like Task Manager to their functions is a common example of exam testing. Key terms for review in this topic include Task Manager, Process, Service, Driver, Administrator, Power Profile, plug and play, and resource monitor. Reinforcing these definitions through flashcards and guided exercises helps commit them to memory. Grouping terms by hardware management, software management, and user access functions supports quicker recall during both real-world application and exam conditions. In real-world IT environments, operating system management skills are used daily by technicians and administrators. These skills apply to installing and configuring hardware, monitoring tasks and resources, and setting user access levels. A solid understanding of device behavior, process management, and security permissions contributes to improved performance, stability, and end-user satisfaction. These capabilities are foundational for both entry-level and advanced IT positions. In the next episode, we will focus on how software is used in everyday business and personal environments. This will include productivity tools, collaboration applications, and support utilities. You will learn to recognize software categories and understand when and how to use them effectively in different settings. Join us for Episode 37, Software Use Cases, Productivity, Collaboration, and Support. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.